Right now, as you watch this video, light from the sun is traveling toward you at 299,792 kilometers per second. It left the sun approximately 8 minutes and 20 seconds ago, which means if the sun vanished at this exact moment, you wouldn't know for over 8 minutes. The sky would still be blue, birds would still be singing. You would have absolutely no idea that the star keeping every living thing on this planet alive had simply ceased to exist. So what happens next? Minute by minute, day by day, year by year. Let's find out exactly how long humanity would survive and what the end would actually look like. The final 8 minutes. For exactly 8 minutes and 20 seconds, nothing changes. The sun is gone, but its light is still en route, an 8-minute-old ghost of a star that no longer exists. Then the countdown hits 0. Darkness. Total, absolute darkness falls across the Earth's sunlit side. Not like night. Night still has the moon, the stars, the ambient glow of distant light. This is different. This is the absence of our nearest star. The temperature begins to drop immediately. Not catastrophically and not yet, but the process has begun and it will not stop. The first 24 hours. Within hours, surface temperatures begin their descent. The oceans, which store enormous amounts of thermal energy, act as a buffer. Coastal areas stay relatively warmer for longer. But inland regions, especially at higher altitudes, begin cooling rapidly. Within 24 hours, average surface temperature drops to around -17 degrees Celsius. That's the average temperature of Siberia in January, applied to the entire planet simultaneously. Plants begin to die almost immediately. Without photosynthesis, the oxygen production cycle halts. The base of every food chain on Earth is severed in a single day. Governments scramble. Emergency broadcasts go out. But what can you prepare for when the sun is simply gone? Week 1 to 1 month. Within a week, the surface temperature averages -40 degrees Celsius worldwide. The oceans begin to freeze from the surface down. Not all at once. The sheer thermal mass of the world's oceans gives them remarkable inertia. But coastlines freeze, rivers freeze, lakes freeze. Fresh water becomes critically scarce as water treatment systems fail and pipes burst across the planet. Here's the key to survival in this scenario: geothermal energy. The Earth's core maintains temperatures of around 5,500 degrees Celsius, roughly as hot as the surface of the sun itself. Geothermal vents and volcanic regions become the most valuable real estate on the planet. Iceland, New Zealand, Japan. Countries with significant geothermal infrastructure suddenly become humanity's best hope. One year later. After 1 year, the surface temperature stabilizes at approximately -73 degrees Celsius. At this point, the atmosphere itself begins to change. Nitrogen and oxygen, supercooled, begin to condense and fall as liquid rain, a phenomenon we've only ever seen on worlds like Titan and Neptune. The Earth becomes an ice world, a snowball planet. But here is the extraordinary thing. Life doesn't end. Deep ocean hydrothermal vents, cracks in the ocean floor where superheated water from the Earth's core erupts into the deep sea, maintain temperatures above freezing. Entire ecosystems already exist there, completely independent of sunlight. Chemosynthetic bacteria, tube worms, blind shrimp. They have lived without the sun for millions of years already. They don't need it. If humanity manages to reach these environments, to build deep-sea habitats powered by geothermal and nuclear energy, a version of human civilization might persist. What else disappears with the sun? Here's what most people don't consider. It's not just light and heat we lose. The sun's gravity holds our solar system in shape. Without it, the planets, including Earth, would no longer orbit anything. We would fly off in a straight line into the interstellar void at 30 kilometers per second. In about 1 to 2 million years, a geological blink, Earth would drift into the Oort cloud, the vast shell of ice and rock at the edge of our solar system. In tens of millions of years, we would begin to approach the nearest star system, Alpha Centauri, 4.2 light-years away. Mathematically, Earth becomes a rogue planet, a frozen, dark, dead world drifting through the galaxy for eternity. And yet, the laws of physics tell us that inside Earth's crust, radioactive decay will continue generating heat for another 5 billion years. The planet's core won't cool for another 10 to 20 billion years after that. The fire at the center of this world will outlast the star that gave it life. Could humanity survive? So here's the honest answer. Most of us would not survive beyond the first year. The cascading failures, food supply, water supply, power grids, atmosphere, would overwhelm our current infrastructure within weeks. But some of us might. Survivors near nuclear power plants, geothermal vents with access to underground farming and hydroponic technology. A small, deeply technical remnant of humanity, living in the bones of a frozen Earth. We would be changed, barely recognizable, but alive. And perhaps, in some impossibly far future, our drifting world might pass close enough to another star that life could begin anew on its surface. The universe is under no obligation to give us a happy ending, but it has given us 4.5 billion years of sunlight already. Maybe that's enough.